students. The Module 5, that is Manufacturing Control and Automation. The very first bit is Cnc Technology and Overview. The word CNC came into existence in 70s when microprocessors and microcomputers replaced integrated circuits, IC-based controls used for NC machines. The development of numerical control owes much to the United States Air Force. The concept of NC was proposed in the late 1940s by John Parsons, who recommended a method of automatic machine control that would guide a milling cutter to produce a curvilinear motion in order to generate smooth profiles on the workpieces. In the year 1949, the US Air Force awarded Parsons a contract to develop new type of machine tool that would be able to speed up production methods. Now, with respect to the introduction to NC, CNC and DNC machine tools, the numerical control, that is NC, is a form of programmable automation in which the mechanical actions of a machine tool and other equipment are controlled by a program containing coded alphanumeric data. The alphanumeric data presents relative positions between a workhead and the work part, as well as the other instructions needed to operate the machine. The workhead is a cutting tool or other processing apparatus, and the work part is the object being processed. When the current job is completed, the program of instructions can be changed to process a new job. The capability to change the program NC makes suitable for low and medium production. It is much easier to write new programs than to make major alterations of the processing equipment. Numerical control or NC can be applied to a wide variety of processes. The applications divided into two categories: machine tool applications such as drilling machine, turning, milling and other metalworking, and non-machine tool applications such as assembly, drafting and inspection. The common operating features of NC is all of these applications in control of the workhead movement relative to the work part. In modern NC technology, the machine control unit MCU consists of a microcomputer and related controls hardware that stores the program of instructions and executes it by converting each command into the mechanical actions of processing equipment, one command at a time. The related hardware of MCU includes components to interface with the processing equipment and readback control elements. The MCU also includes one or more reading devices for entering part programs into memory. The type of readers depends on the storage media used for part programs in the machine shop. The MCU also includes control systems, calculations, algorithms, and translation software to convert the NC part program into the usable format. The MCU, because the MCU is a computer, the term computer numerical control is used to distinguish this type of NC from its technological predecessors that went based early on hardwired electronics. Today, virtually all the new MCUs are based on computer technology. The third basic component of NCU system is processing equipment that performs useful work. It accomplishes the processing steps to transform the starting workpiece into a completed part. Its operation is directed by the MCU, which in turn is driven by instructions contained in the part program. In the most common example of NC machining, the processing equipment consists of the work table and the spindle as well as the motors and controls to drive them. Next one, that is computer numerical control. Since the introduction of NC in 1952, there have been a dramatic advances in the digital computer technology. The physical size and the cost of the digital computer have been significantly reduced. At the same time, that is, computational capabilities have been substantially increased. It was logical for the makers of NC equipment to incorporate these advances in the computer technology into their products, starting first with the large mainframe computers in the 1960s, followed by the mini computers in 1970s and microcomputers in the 1980s. Today, NC means computer numerical control. Computer numerical control (CNC) is defined as an NC system whose MCU is based on a dedicated microcomputer rather than on a hardwired control. CNC machines can be used as standalone units or in a network of machines such as flexible machine centers. The controllers uses a permanent resident program called an executive program to produce the codes into the electrical pulses that control the machines. In other CNC machines, executive programs resides in the ROM and all the NC codes in RAM. The information in ROM is written into the electronic chips and cannot be erased, and they become active whenever the machine is on. The contents in the RAM are lost when the controller is turned off. Some uses special type of RAM called as CMOS memory, which retains its contents even when the power is turned off. The last one, that is direct numerical control. The first attempt to use digital computer to drive NC machine tool was DNC, that is direct numerical control. This was in the late 1960s, before the advent of CNC. As initially implemented, DNC involved the control of the number of machine tools by a single mainframe computer through direct communication and in the real time. Instead of using a punched tape reader to enter the part program into the MCU, the program was transmitted to the MCU directly from the computer, one block of instructions at a time. This mode of operation was preferred by the mainframe behind the tape reader, that is BTR. The DNC computer provided instructions blocked to the machine tool on demand. When a machine needed control commands, they were communicated to it directly or immediately. As each block was executed by the machine, the next block was transmitted. As far as the machine tool was concerned, the operation was no different from that of a conventional NC controller. In theory, DNC relieved the NC system of its least reliable components, the punch tapes and tape reader. The system consists of 4 components: central computer, bulk memory at the central computer, set of control machines, and telecommunication lines to connect the machines to the central computer. In operation, the computer called the required part program from the bulk memory and it's sent back to the designated machine tool. This procedure was replicated by all the machine tools under the direct control of the computer. One commercially available DNC system during 1970s claimed to be capable of controlling up to 265 machines. Now, the classification of NC machine tools. According to the type of power to the drives, there are 3 main subclassifications, that is electrical, hydraulic, and pneumatic. And second main classification is according to the motion control of slides. point-to-point systems and counter or continuous path systems. These are the other two. And the third type, according to the feedback systems, open loop system and closed loop system. These are the two sub-systems. According to the axis identification, 2-axis, 3-axis, 4-axis, and 5-axis systems. So these are the classifications of NC machine tools. Now the classifications of CNC machine tools based on the motion type, point-to-point and countering systems. There are the main two types of machine tools and control systems required for use with them differ because of the basic differences in the functions of the machines to be controlled. They were known as point-to-point or countering controls. Point-to-point systems, that is the second type of CNC machine tool. So some machine tools, for example, drilling, boring, and tapping machines require the cutter and the workpiece to be placed at certain or fixed relative position at which they must remain while the other does its work. The machines are known as point-to-point machines and the control equipments for use with them are known as point-to-point control equipments. The feed rate need not be programmed. In these machine tools, the axis is driven separately. In a point-to-point control systems, the dimensional information that must be given to the machine tool will be a series of required position of the two slides. Servo systems can be used to move the slides, and no attempt is to be moved the slides until the cutter has been retracted back. The countering systems, the other type of machine tools, involves motion of the workpiece with respect to the cutter while cutting operation is taking place. These machine tools include milling, routing machines, etc., and are known as countering machines shown in figure. And these controls required for their controls known as countering controls. Countering machines can also be used as point-to-point machines, but it will be uneconomical to use them unless the workpiece also requires having a controlling operations to be performed on it. These machines require simultaneous control of axis. In countering machines, relative positions of the workpiece and the tool should be continuously controlled. Now, based on open loop and closed loop systems, programmed instructions are fed to the first one, that is, in case of open loop systems, the programmed instructions are fed into the controllers through input devices, and these instructions are then converted to the electrical pulses by the controllers and sent to the servo amplifier to the engines, the servo motors. The primary drawback of the open loop system is that there is no feedback system to check whether the program position and velocity has been achieved. If the system performs its affected by the load, temperature, humidity, lubrication, then the actual output could deviate from the desired output. For this reason, the open loop system is generally used point-to-point systems where the accuracy requirements are not critical. Very few continuous path systems utilize open loop controls. In case of closed loop systems, there is a facility of feedback. The feedback systems could be either analog or digital. The analog systems measure the variation of physical variables such as position and velocity in terms of voltage levels. Digital systems monitor output variations by means of electrical pulses to control the dynamic behavior and the final position of the machine slides. A variety of position transducers are employed. The majority of CNC systems operate on a servo mechanism, a open loop principle. If a discrepancy is revealed between where the machine elements should be and where it is actually is, the sensing device signals the driving unit to make an adjustment, bringing the movable component to the required location. Closed loop systems are very powerful and accurate because They are capable of monitoring and operating conditions through feedback subsystems and automatically compensating for any variations in real time. Now, based on the 3 axis, that is 2, 3, 4, and 5 CNC machines. So, in case of 2 and 3 axis CNC machines, CNC lathes will be coming under 2 axis machines. There will be 2 axis along motion takes place. The saddle will be moving longitudinally on the bed, and the cross slides move transversely. The saddle. Okay, in the 3 axis machines, there will be one more axis perpendicular to the above 2 axis. In case of 4 and 5 axis CNC machines, a multi-axis machining capabilities beyond the standard 3-axis CNC tool path movements. A 5-axis milling center includes the 3 XYZ axis, the A axis, which is rotary tilting of the spindle, and B axis, which can be rotary index table. In case of 4 and 5 CNC machines, these provide multi-axis machining capabilities beyond the standard 3-axis CNC tool path movements. A 5-axis milling center includes the 3 XYZ axis and A axis, which is rotary tilting of the spindle, and B axis, which can be the index table. Now, based on the power supply, that is electric, hydraulic, and pneumatic drives, mechanical power units refers to a device which transfers some forms of energy to mechanical power, which may be used for driving slides. In case of electrical systems, the electric motors may be used for controlling the both positions and countering machines. They may be either AC or DC motors, and the torque and directions of rotation to be controlled. The speed of the DC motor can be controlled by varying either the field or armature supply. In case of hydraulic systems, it may be used with the positioning the countering machine tools of all sizes. These systems may either in the form of rams or motors, hydraulic motors, or smaller than electric motors of equivalent power. Now, there are some advantages of CNC machines. CNC machines can be used continuously 24 hours a day. CNC machines are programmed with a design which can be manufactured hundreds or even thousands of times. The third advantage, less skilled or trained people can operate CNC, unlike manual lathes, milling machines, which need skilled engineers. The fourth one, CNC machines can be updated by improving the software. The fifth one, training in the use of CNC is available through the use of the virtual software. And the sixth advantage, CNC machines can be programmed by advanced design software such as Pro or desktop. The next advantage is modern design software allows the designer to simulate the manufacturer of his or her idea. And the last advantage, that is one person can supervise many CNC machines. Now, at the same time, there are some disadvantages also. CNC machines are more expensive, and CNC machines operate only, the operator needs only the basic training and skills enough to supervise several machines. Fewer workers are required to operate CNC machines compared to all manually operated machines. Investment in CNC machines can lead to the unemployment. Many countries no longer teach pupils or students how to use manually operated lathes, milling machines, etc. Students no longer develop detailed skills required by engineers. Some applications. The applications of CNC machine include both machine tools as well as a non-machine tool area. In the machine tool category, CNC is widely used for lathe, drill press, milling machines, grinding units, laser, sheet metal processing, working machine, tube bending machines, etc. Thank you.